ado, today we're going to be talking about AC and DC coupling a PV system with SimpliPhi batteries. For those of you who do not know, we have actually been around for 12 years now. We were founded in 2010 as OES Energy. Also produced some items under the name Liberty Pack. You may have seen the Liberty Pack units if you are a filmmaker. We actually started making mobile power packs for Hollywood filmmakers. There were a lot of kind of drawbacks to other lithium packs that weren't as safe, or even not non-lithium mobile packs were just way too heavy back in the day. We've got a few batteries still on the wall as OES Energy, so note that we, our batteries are out in the field, outliving their warranty already, and you may see them under a different name, but that's still our product, same people, same company. Beyond that, in 2011, we pitched ourselves to the military for a project, and they basically said they did not even want to consider lithium batteries for their project. They did not feel they were safe enough at the time. However, we were able to convince the military to do some testing of our batteries at the Aberdeen Proving Ground testing location in Maryland, which is not far from my house, where I grew up. No longer live there, but would always hear, explosions of test equipment, and that was fun back in the day to know that was nearby and testing was going on there. The military did end up testing our product and deciding it was, in fact, meeting the safety needs of that project. So that was a big step forward for lithium batteries at the time. We also moved into emergency response with smaller mobile power units, as well as the residential market during that time. And in 2013 and 14, we kind of added some variety to our product line. We want to keep in mind the installer and the customer, right? So not just what are we able to manufacture, but what do you guys need as an installer to make your job easier, and what are the customers asking you for? So I know we've got a lot of installers on here today. If you have, feedback about your experiences with our products, please do send it to me. I'd be happy to take it into consideration and see what I can do to help you. In 2015 and 16, we actually relaunched under the name SimpliPhi Power. So that is when we became who we are today. And then from there, we have been working to ramp up our manufacturing capacity. In Ventura County is where we manufacture. There is a problem out there that we are trying vigorously to solve. There's a limited access to safe, reliable, affordable, and sustainable power. So here in the US, electricity costs have risen over 15% in the last 10 years. And for me here in California, it's actually much more than that. I'm paying between 35 and 45 cents per kilowatt hour right now. It's on a, time of use rate structure. We have the option to choose from time of use or tiered, which is, the utilities coming up with all these creative ways to charge you more, like peak power usage, etc. So we're going to talk a little bit more about that today, but the US is not the only place where power costs are rising. This is really happening all over the world as well. On top of that, infrastructure is failing. So we're talking about public safety power shutoffs in California. We're talking about Texas cold weather utility freezes. We're talking about transformers in average neighborhoods that are simply overloaded by the day and cool down at night. Now with the addition of EVs, they're not cooling off at night. So these transformers and outdated utility infrastructure is starting to fail and fail hard. And the solution to this is distributed assets. Distributed assets are going to give customers control over their own power. So, keeping your lights on when the rest of the world has the lights off, that's something that we want to make possible. We want you to be able to choose your generation source, so understanding where your energy is coming from. Is it a clean source? Is it local, etc.? And through this, we hope that it will assist in decarbonization. So, being able to not rely on the utilities to simply accept whatever mix of power generation they give you, whether it's 80% coal and 20% solar, or, instead of being able to come up with your own mix and generate your own electricity, effectively decarbonizing the electricity supply. AC and DC coupling relates to how solar panels are coupled or connected to the battery bank. AC coupling means that the PV array is producing AC power on the roof or at the string inverter. So the DC power from the PV array is immediately converted to AC. AC power is coming off the roof or the wall, and then that's converted to DC again to charge the battery. This is not to be confused with grid-tied solar, which is just a PV array that converts to AC power that then gets sent directly to the grid loads immediately. We're talking about coupling as it relates to adding a battery bank to the system. DC coupling is when you use a PV array to produce DC power, and that DC power is connected directly to the battery bank with no AC conversion there. Now, you'll always have a charge controller of some sort to kind of monitor that power and regulate it, but you don't have to convert it to AC. So we'll dive a little deeper into DC coupling first, then we'll get to AC coupling, talk about some applications, and then talk about how our products fit into all this. DC coupling, as an overview, is when you generate DC power and charge the batteries with that DC power. You're going to need a charge controller that's going to control the DC voltage and amperage that's supplied to the batteries. And it's also going to optimize your power source production. So a charge controller is, monitoring the voltage that the PV array sits at and how much power it's producing in total. And it's always going to make slight changes to those conditions to try to get it to produce more power. We'll talk a little more about how that works. One thing to consider with a DC coupled PV array is shading. When you have a string of panels in series and one of them gets shade on it, let's say it's completely shaded, it's producing no power, then guess what? That entire string is producing no power. That series string is dead. Now think of this, if you're unsure why this is happening, think of the PV string as a water pipe. If one of those panels is shaded, that's effectively a valve shutting off that pipe, and no water can flow through that pipe. So this is something to consider if you have shading, affecting your array for multiple hours of the day, then you need to mitigate this somehow. Whether you rearrange the PV array or you use DC optimizers, this is something you need to mitigate, or it will kill your panel's production. Another thing to consider here is string open circuit voltage and short circuit current, as well as max power voltage and max power current. So really what I'm talking about is matching your array and your strings to the right charge controller. You want to make sure that the charge controller can accept the full open circuit voltage of the string. That's the most important thing. All these specs will be available on the spec sheet of your charge controller and your panel. So if you've got a maximum open circuit voltage on your panel of 40 volts, and you got 3 in series, you need to be sure your controller can handle 120 volts open circuit. Now, actually, I would say you need to add at least 10% room. In cold environments and cold places, your open circuit voltage will rise as the temperature drops. So if you've got a 120 volt rating for your open circuit on your string, make sure your controller can actually handle more like 132 volts open circuit. Short circuit current, you simply want to make sure the controller can handle the maximum short circuit current that the array can provide. All right, so what does a charge controller do? How does it work when you're DC coupling? First off, a charge controller is going to regulate that DC voltage for charging the bank and, if needed, limit the current that's going into the battery bank. This is going to hit specific set points that you've often programmed into the controller as the user. And it can accept, usually most charge controllers can accept any DC power source such as PV, wind, or even hydropower. There are 2 different main types of charge controllers, MPPT and PWM charge controllers. Now I'm going to talk a little bit more about these in just a second. Hang tight there for a quick intermission. Just 30 seconds here. All right, so MPPT stands for maximum power point tracking. Maximum power point tracking is going to see the solar panel voltage at all times. And it's then going to say, okay, right now I'm sitting at 100 volts. If I increase the array voltage to 100.2, are we producing any extra power? No? Okay, how about 99.8? Any extra power there? No? Okay, back to 100. We're at the max power point, producing the most it can at all times, always tracking that curve. And this is going to be up to 99% efficient. And you know, the efficiency will change with load. So if you're running a full load on this charge controller, it's going to be very efficient. Maybe a half size load, not quite as efficient, but still well above 90% efficient, usually between 97 and 99% efficiency of a charge controller. Now, the other type of controller called PWM, that stands for pulse width modulation. Pulse width modulation means that the charging power of the charge controller is simply going to flicker on and off very quickly for these micro bursts. And it's going to use FETs, which is basically a switch that can switch on and off very, very fast to turn on and off that, you know, power being provided to the battery. By turning it on and off very quickly, the battery is going to see the average voltage and current that it's being provided. Instead of, you know, seeing 60 volts and 0 volts, it's really just going to see the average of the voltage it's provided. So this is going to be less efficient than MPPTs in most scenarios. However, it is cost effective and pretty efficient still for smaller arrays. I'm talking about 1 kilowatt or so. You rarely, if ever, will see these for arrays larger than 2 kW. So normally we're talking about, you know, sheds or vans, you know, small systems that are under a kilowatt that are using PWM, mostly for cost advantage. All right, any questions here? I don't see any questions. I'm going to move on for now. We can always come back to this. So what lands on the DC bus when you're DC coupling? Let's look at the system design. First off, of course, the battery is going to land on the DC bus. So you know how to parallel wire SimpliPhi batteries, all same length, same gauge cable, of course, so the lithium batteries can be well balanced. But did you know that the charge controller and inverter also land on that DC bus? So this is going to allow the charge controller to push and pull power from the battery bank, and at the same time, the inverter can draw power from that same DC bus as well. So I remember when, fancy new inverters were hitting the market when I was studying them in school, and they were coming out with this battery bypass feature. So they claimed they could take power from the PV array as it was coming in, and never have to charge the battery bank from it. Now, I think that's a little bit of a hoax feature because the DC bus bar does this automatically. If you have, 80 amps coming in from your PV array and 80 amps going out to your loads, I would really take the time to put an amp clamp on your battery bank wires and check how much power is going in and out of them. It should be very, very close to 0 amps in that scenario. And it is, it's what I've seen happen. So your DC bus bar already allows, power to bypass the battery bank without charging and discharging those batteries rapidly. And this is the DC bus bar that I'm talking about. Another design here, just to kind of highlight that sometimes the DC bus bar is hidden within the inverter already. So you may have a DC connection for your batteries and your PV array at separate locations within the inverter, and you might not see it visibly, but they are on that same DC bus somewhere internally. So let's talk a little bit about AC coupling as well. Now, I'm going to be honest here. I come from the off-grid world, and I much prefer DC coupling. But AC coupling definitely has its advantages in grid-tied systems. I'm not going to deny that. So please, please jump in with questions at any time. Give an overview of AC coupling. This is AC power coming off the roof. So you're probably a little confused here. Don't PV panels produce DC power? Yes, they do, but in an AC coupled system, you've got either a string inverter or a microinverter on each string of panels or on each panel individually, immediately converting that power to AC power. Now, the main reason panels are put in this way is often because either it's easier to wire or you're first installing a system without batteries and you don't even know that you might add batteries later down the road. So putting in a system without batteries, you'd be using either a what they call a string inverter, which is a full string of panels coupled on the roof to an inverter on the ground or the wall, and then also the option to use microinverters on each individual panel. These can also be called PV inverters or grid-tied inverters. When you're AC coupling, everything is in parallel essentially. So if you've got a microinverter on every single panel and one of them is shaded, nobody cares. That one panel is not going to have an output, but the rest of them will output as usual as normal. So this is one reason why AC coupling is a bit easier. There's essentially an optimizer on each panel with the microinverter. Now, in this configuration, the battery bank would be charged through the inverter's internal charger. That's going to convert AC to DC. So normally, an inverter converts DC power or battery power to AC power to power the loads. In this case, when charging the battery, the inverter's charger is simply the inverter running in reverse. I've heard Eric Benson use this term, in some of his trainings. If the inverter is working, the charger should work as well. And using a generator is effectively the same thing as AC coupling. I mean, when you look at the system design, it's really going to be the same. Obviously, there's a few differences, but they're small. So one important thing to talk about regarding AC coupling is frequency shift. Frequency shifting is a mechanism that battery-based inverters are going to use to control a grid-tied PV inverter's output. So think about this here. You've got your battery bank, and the grid is down. So the grid is off. And your PV array is producing full blast power to charge that battery bank. And your battery bank begins to get full. What happens? Well, the battery-based inverter is going to sense that the batteries are full, and it's going to send a signal to the microinverters to tell them to stop producing power. That signal is called frequency shifting. So the battery-based inverter is going to, instead of producing 60 hertz, it will usually increase frequency slightly. So maybe 60.1 hertz, and it'll say, okay, 60.1 hertz, I'm going to produce a little less power. 60.2, half as much power. 60.3, a quarter as much power. And 60.4 or 5, shutting off completely for the microinverters. As soon as it sees a frequency that's outside of what it thinks the grid could produce, it's going to shut off for safety reasons. You can't have your AC coupled array sending power back to the grid when the utility workers are doing maintenance on it. That could cause injuries. So they shut off when they do not see a grid signal. Another thing to think about here, though, is if you're installing a brand new battery-based inverter and you've got 10-year-old microinverters on your roof, are those compatible? So you've got to check into that. You've got to call the manufacturers and ensure that both the inverters are compatible and that they even have frequency shifting capabilities if it's older. All the newer ones, of course, will have this, but the older inverters sometimes do not have this. Here's why I think AC coupling is so popular is because grid-tied PV is so popular. This is how simple it is to install grid-tied PV. You've got the customer's main panel and you just put on some solar panels and microinverters and a critical loads panel, or even sometimes just this serves as a disconnect. Often there's no loads actually on this panel. It's just serving as a disconnect. So between these two is where you're going to throw your battery-based inverter and batteries. So this is why AC coupling is popular, is all your equipment is already outside and you can simply toss in a outdoor rated cabinet like our access unit and then have all that equipment outside. It's an easier installation in general. All right, so we've talked about what AC coupling is and what DC coupling is, some of the equipment involved. I want to talk about applications of both of those, where one is a better fit than the other, and then we can talk about SimpliPhi products. All right. So if you're off grid, I think DC coupling is usually the way to go. One thing to keep in mind, however, is you need to maximize your float charge. So if you're off grid, you want to go to bed with a full battery bank. You don't have the ability to use the grid anytime your battery bank is depleted. So you want to make sure that when the sun goes down, before it goes down, you've been in float charge mode all day until then, maximizing your solar production so that you don't begin drawing on your battery bank before the sun goes down. In a battery backup system, so a grid-tied system, this is often known as a hybrid system. So you've got the grid and the batteries, but if the grid goes down, your equipment can disconnect from the grid and function in island mode. So keeping, the DC coupled PV array on is no problem for that inverter. The DC coupled PV is not even going to notice that the grid ever went out. You're able to easily sell to the grid if the grid is on. You're able to easily separate where your power is coming from. So your inverter can see, okay, the grid is over here on the AC bus, the PV is over here on the DC bus. Right now, I've been programmed to use only DC power or renewable energy because it's 5 to 9 p.m. and the grid power is more expensive right now. I'm not going to use power from the AC bus. Instead, I'm going to sell power to the AC bus because time of use is, advantageous to sell right now. So having DC coupled systems that are grid tied, it really gives you the maximum amount of control over where your power is coming from and where it's going. When you look at an AC coupled grid tied system, that power is all on one bus. So your AC coupled PV array and your AC power coming from the grid, it's all on one bus. So it's hard to separate what power is coming from where. The best you can kind of do is disconnect from the grid during those time of use hours when power is expensive. It's hard to say, oh, I'm only going to sell to grid when power is expensive, because who's to say you can't have power flowing both ways in that situation? When you're AC coupling, this is rarely done with off-grid systems. Sometimes with massive off-grid homes, I do see AC coupling. Either the installer is more comfortable already with the equipment, so they just use it, or what is often the case is the PV array arrangement considerations, cost, or simply the installation time, and effort and considerations with the PV array just made sense to do AC coupling. Again, this is rare only for systems with unique features like shading, or if they're just very large and time plays a big role in the cost of the system. However, keep in mind, if you're grid tied, then that grid down situation, when it occurs, you need to be prepared for that frequency shifting to occur. You got to make sure that's built into your system. Otherwise, when the grid goes down, your PV array will not be producing power. So if your battery-based inverter cannot produce a grid signal or frequency shift, then you will not be able to, produce power when the grid goes down. And this is something that I think a lot of simply grid-tied PV customers don't realize. They buy a PV system and don't realize that their power is not going to stay on during an outage. And the fact is that if you don't have batteries, that is not a distributed asset. That's a distributed generation source. But you don't have control over that power until you add batteries and a battery-based inverter. So we got a good question here. I think I misspoke there. The ability to frequency shift does not mean your array will always turn off when the grid is down. The ability to, produce a grid signal when the grid is down and disconnect from the grid is what keeps your PV array, your AC coupled PV array, on in an outage. Frequency shifting is going to allow you to more closely regulate that AC power, keeping it able to almost fully charge the battery bank and kind of taper off towards the end, instead of simply having it shut off and turn back on full power and shut off and turn back on. So frequency shifting is not what keeps your lights on in a grid outage. So we've got a good question here. What's the impact of not having frequency shifting? For example, an old Outback FX 3648 is AC coupled to an SB 4000, but the VFX does not have frequency shifting. The existing batteries are AGM. Sounds like you want to switch them over to Phi. Can this be done? Yes, so this can be done without frequency shifting. You need to make sure that, and I would check this with the lead acid batteries before you put on the lithium batteries, check that the, when the battery-based inverter senses the batteries are full, check that it actually turns those microinverters off, or excuse me, that string inverter off quickly and effectively. Make sure that battery voltage is not rising above what it should be and what you've programmed into that system in the Mate 3. So if that, system is actually working well and turning off and charging the batteries as you've programmed it, sure, you can add those in, and you don't actually necessarily need frequency shifting. It's going to make things more seamless, but I understand not having it. It's totally going to be okay without that. I would say definitely reach out to us and we can help you, with tech support on this one. Sounds like it's a little more in depth, but that's a good question and a timely one at that. All right, so existing PV and should you AC or DC couple? So rewiring an existing AC coupled system for DC coupling can be a lot of time and effort, and realistically, it's not often done. I would say that if you've already got an AC coupled system in there, the advantages may not outweigh the cost. As long as you're happy with the specs of your old system, I would say keep it in there. If you've got a brand new system, I would really say that the advantage of DC coupling is always the way to go for a brand new system in most cases. Let's consider efficiency here. So PV with AC coupled is going to have a 4% loss through that microinverter, and then another 4% loss when charging the batteries through the battery-based inverter. 2% loss round trip in and out of the batteries, and then another 4% loss through that battery-based inverter to the loads. So you're going through the micros, through the batteries, through the micros, through the battery-based inverter, through the batteries, back out through the batteries, back out through the battery-based inverter to the loads. That's a lot of travel for that electricity. It's going to take a couple extra hits in efficiency there. Whereas a DC coupled system, it's going from the PV to the charge controller, smaller loss, through the batteries, and then out through the battery-based inverter. It's a much quicker trip there and a more efficient trip. This assumes, though, that you're always charging the batteries before powering the loads. The argument I often hear is, well, I'm going to go with an AC coupled system because I'm, sending all the power to the loads immediately. This is really not the case. What you're not realizing is you're not really using power when it's being produced. So you're not often home between 10 a.m. and 4 p.m. And even if you're home, you're not using your lights. It's a very minimal energy draw during the day. So the time the power is produced does not match the time that you're going to be home to use it. However, if it's a, purely AC coupled, purely grid tied PV system, no batteries, sure, that's very efficient. It's just sending power right to the grid. It's just that 4% loss from a micro and then right to the grid from there. That's it. So that's super efficient. But what I find is that's not often the customer's use case. So rapid shutdown is a highly debated topic amongst DC versus AC coupled systems, and really it's not that different. I think what's causing it to differ more is where you live and your jurisdiction's requirements. So always, first off, as a disclaimer, always check with your local jurisdiction and make sure you understand what your inspector wants to see on your rapid shutdown. Some of them, if you've got a ground mount system, you can often get away with just a shutoff box for that ground mount array. But if you've got panels on your roof, many times you're required to have module level shutdown, which is either a DC optimizer for your DC coupled array or rapid shutdown only attachments. Tigo makes both of these as an example. Sometimes you'd need a way to remotely shut down the whole system with one button. So this is something we're seeing increasingly in AC and DC coupled systems alike across multiple jurisdictions, but I'd say the more strict ones first are actually requiring a single button that you can press that's accessible to firefighters, near the system, in the garage or outside, that is going to disconnect the batteries, disconnect the PV array, and turn off the inverter all in the press of one button. Now, this specifically is a big selling point for the SolarArc inverter because it has all these features built into it. It's got this ability to have a single button be pressed and cause all this to happen. Now, with AC coupled PV systems, if you've got an existing array that's grid tied and then you add batteries into it, usually that does not change the rapid shutdown compliance of your PV array. So whatever you've got already, you're probably good to go. You're probably grandfathered into whatever it is you've got up there. But the batteries may or may not require certain rapid shutdown depending on where you are. So mostly they do not. But then again, sometimes you've got to have that single button. So that's something you'll have to look into and consider as an installer before applying for the permit or during the permit process to make sure you meet those requirements. As an example, a DC coupled system, maybe you've got almost always there's a PV disconnect box in general, but maybe you've got the Tigo rapid shutdown attachments or the optimizers, so the TS F-4 or -0, and you've got this button for shutting them down. This button is going to kill the power to the transmitter, and when the rapid shutdown modules don't see power from the transmitter, they're going to kill the PV array. This button is also going to disconnect the batteries right here and just turn off the inverter in general and shut it down. Now, one thing to note is that if you've got an AC coupled system and let's say you don't need that rapid shutdown single button, then you can probably just get away with a disconnect here, just a PV array disconnect. Some system design considerations. So when you're DC coupled, you can pretty easily overload that charge controller and it will accept as much power as it can handle and simply not accept the rest of the power. So you can often put maybe a 10 kW array on a 7 kW charge controller, no problem, it'll just accept 7 kW. This is common for areas where it is cloudy most of the time or the array maybe isn't oriented perfectly. You're able to combine PV runs with combiners. Now this can be a little bit of a hassle, to be honest, when you have multiple strings coming off the roof and needing to use a combiner is an extra part to throw into your system. So keeping those wire runs short and just keeping wires to a minimum is always to your advantage. This is another reason AC coupled systems are popular, is because you can have larger strings and less wiring in general. Now, one thing to understand though is sizing is much more critical with an AC coupled system. So with a DC coupled system, you're worried about open circuit voltage and short circuit current. With an AC coupled system, you're worried more about sizing. So you're looking at this microinverter specs and it says I can only handle 310 watts, but you can overload me as much as 50%, for example. So understanding how far you can overload these microinverters is important. And then also just knowing that limiting amperage through an inverter's internal charger is not as reliable as limiting it through a charge controller. Some inverters don't even have the ability to limit that charge current. And the power output of the inverter. Most of them do, I would say. All of the new inverters coming out have these settings, but some of the older ones do not. Another thing to keep in mind here is, so we talked about frequency shifting and that, AC coupled array disconnecting from the battery bank. So if you've got a very small battery bank and a very large PV array, and that PV array is selling power to the grid, full power, 10 kilowatts to the grid, let's say. And then all of a sudden the grid disconnects. So in that 1 second, a small portion of a second even, maybe that it takes the microinverters to stop producing such a large amount of power, they have to send it somewhere. And it goes to the battery bank because there's nowhere else to send it. What that causes is a DC voltage spike of these battery banks. Now, a lead acid battery bank, you overcharge it a little bit, the voltage rises a little bit, no problem. With a lithium battery bank, when it gets to the top of its charge cycle and it's full, a very small overcharging event can cause a very quick voltage spike. And this will not only affect the batteries and the inverter, but if it's bad enough, it can even pass on to the AC side, such as the appliances and the microinverters can see that AC voltage spike as well. So really, when you're designing an AC coupled project, sizing is much more key. You have to make sure that you're not overloading those micros and you're not overloading the battery bank and charging that faster than it can be charged as well. So some key features of our products, how we fit into all this, is we use lithium iron phosphate batteries only. That's our only chemistry that we have ever used and will ever use, and we use only cylindrical form factors. So this is the safest, most durable, and longest lasting cell that we have found. Pouch cells, they're a little more flexible, prone to puncture, swelling under different temperatures or rugged conditions. Prismatic cells are great, but don't have the, I would say, protection and lifespan of a cylindrical cell. All of our products are UL certified where applicable. So if you're not familiar with UL, this is a third-party lab that's going to safety test all our products where applicable and certify them as safe. Now, mostly these certifications they relate to fire testing and fire safety, but they're often needed, required for building and fire codes in different jurisdictions. So I'd say increasingly, inspectors are looking for UL listed products only. Your batteries needing to meet 1973 is almost a given across all jurisdictions, whereas UL 9540 certifies the system as a whole, so the batteries and inverter and any other components all together will be certified under 9540. This is not as commonly required, it's a little more rare, but it's growing in popularity. 9540A is a important test protocol. This is not a certification. It's simply a report that's generated that says, your product has been essentially forced into thermal runaway, and this is how it reacted. So for those of you who are familiar with lithium iron phosphate, it's a very safe, inherently thermally stable product. So this 9540A, forced thermal runaway event, it was extremely uneventful. Whereas a lithium, maybe cobalt oxide battery would easily, catch fire in a thermal runaway event, lithium iron phosphate barely reacts at all, which is a nice reassuring thing for you installers and homeowners to understand. Regardless though, be sure to check with your AHJ so you understand, what UL listings and what building codes you have to meet. So an overview of our products. To begin with, we've got the PHI battery. This is a very simple and reliable battery. We've been making this product for a long time now. It's our most popular product. It operates mostly as a lead acid replacement. So it's got a very simple BMS. There's no communications. It gets wired in very similarly to a lead acid battery, and it's compatible with a wide range of equipment. So if you're retrofitting that old system with the FX inverters you mentioned, JP, this is the battery you're going to want to go with. There's no communications needed. That old equipment is going to be compatible. You'll just reprogram it through the Mate 3. So making sure to change the settings as you add these new batteries to the system is always important, but not having to upgrade to brand new equipment for a savvy customer that's got old equipment, that's a great advantage of this product. Now, you're probably wondering, can this battery do AC or DC coupling? It can do both. So I'll say this again, a battery is a battery. It handles DC power only. So regardless of whether you're AC or DC coupling, you will need a battery-based inverter to handle the charge currents and loads. The battery-based inverter is kind of the buffer and the maintainer of the battery bank. With that, our batteries can be AC or DC coupled. Either way is not a problem. However, 48 volts, keep in mind 48 volts is recommended for AC coupling. A lot of the equipment that has frequency shifting and does AC coupling only operates at 48 volts anyway. Now we also are offering our newer, I would say a more intelligent battery. This is the AMPLIFI battery. It's the same energy capacity of 3.8 kilowatt hours and 75 amp hours at 48 volts. However, this battery is going to intelligently communicate with the Solar inverter or the Sunny Island inverter with closed loop communications. Now again, this can be AC or DC coupled alike. But with this battery, it's not compatible with a whole wide range of equipment. It's just for now, it's just these two inverters until we're able to test more for compatibility. Now, advantages of communications. Not only are you going to see, better performance operating off of a battery that's communicating its state of charge to the inverter and how many amps it can accept and provide to the load, you're also going to be able to see more information as a user. So you're going to be able to monitor your product more closely with current, voltage, state of charge, and temperature readings through the LCD screen of the Solar, through the PowerView monitoring app, or through the website. So this is going to not only let you see real-time data, but also historic data. Now this is super helpful for us in the tech support department when there's an issue and we're trying to troubleshoot. I'd say we solve these 10 times faster when there's accurate monitoring on the system. In addition, it's going to help you out a little bit as the installer by automatically programming certain settings like charge and discharge rates. And it's also going to add another level of protection for cold temperatures and small systems. So those of you who are familiar with sizing our systems, we know that for the PHI batteries, you need, let's say, five of the PHI 3.8s to fully power an 8 kilowatt radiant or a solar 12K. With the AMPLIFI battery, you can start with as little as one battery for a solar 12K inverter. And the reason for this is it can still communicate to the inverter and say, hey, there's only one battery in the bank right now. I can only handle 1.9 kilowatts, so you're going to need to tone it down. As soon as you add more batteries to the bank, they will recalculate that charge and discharge rate and report it again to the inverter. So this is an advantage here, allowing your customer to start with a small system and scale up as they go. Got a question here. What other inverters will the AMPLIFI battery be optimized for and when? For example, how about the Ridian? Right now, we are doing testing with multiple other inverters. We just finished with Sunny Island, but we are testing with Schneider and Victron and hoping to kind of give you guys the feedback there. I'd say Outback is a little bit further down on our list. Probably not going to be anytime soon that we have the AMPLIFI battery connected to Outback inverters. I'd say they're definitely eventually, but not right now. All right, and our access units. So our access units, it's a NEMA 3R rated outdoor ready cabinet that's able to stand up to, harsh weather conditions. This comes either AC or DC coupling, so you can get a Solarc inside that comes ready to be AC or DC coupled, or you can get a Schneider XW Pro, and even you can add on a 600 volt Schneider charge controller if you need. These are going to come with frequency shifting and the newest grid-tied inverter compatibility. So if you're installing brand new equipment with this, it shouldn't be a problem. Keep in mind sizing considerations again for an AC coupled system, a little bit easier to oversize a DC coupled system. They are going to have an automatic transfer switch, so they will operate fully as a UPS with the extremely low transfer time. It's so fast that even your sensitive electronics will not know the power went out. So we're talking about transferring from relying on grid power to then switching over to relying on inverter and battery power. It happens in a matter of a small fraction of a second. This entire enclosure and everything inside of it is 9540 rated, and even multiples of them in parallel are 9540 certified. So this is, I would say, a very popular solution for AC coupling, as all of your AC coupling equipment is already outside. Adding this cabinet in line, as we saw earlier, is easy because you don't have to bring any wiring inside. These units are going to come with a crated delivery. So just rewinding here a bit, the inverter is going to be pre-mounted and pre-wired in the cabinet with the connections kind of hanging loose. And the batteries are going to be sent separately in boxes. So you will have to make those DC connections with the batteries because we want to keep them safe during shipping. But the bus bars are mounted, the inverter's got those wire connections made internally, and the DC connections made. You just kind of need to finish them up. Whether you are AC coupling or DC coupling, or even adding a generator to either of those scenarios, our units are going to have all these connections already built in. Schneider currently cannot communicate intelligently with the AMPLIFI battery. However, you can still integrate it with a Phi battery. With the SimpliPhi, the standard Phi batteries, you can put as many batteries as you need in parallel, but with the AMPLIFI batteries, you can put 75 batteries in parallel. So that's well over 100 that's about 300 kilowatt hours or more. So it's not something that's going to be a limiting factor on residential systems, but maybe on a few commercial systems, you'll want to switch to Phi. Now, this is the Schneider XW Pro inverter that comes in our access cabinet. And remember, you can mount a 600 volt 80 amp Schneider charge controller if you need to. So you'd have to order that in addition. Doesn't automatically come with it, but if you need it, let us know and we'll mount it in there. With the Schneider access unit, you will need a Combox for the monitoring to work. This requires a wireless router. There is real-time and historic monitoring, but last I checked, there is no wireless programming. So remember about the PV limits, and we're talking about AC coupling here. Do not overload the battery-based inverter. It will charge the batteries too quickly and can damage them. With the SolarArc inverter, this is, again, AC or DC coupling. It comes with these built-in, these features, so you don't need to modify the unit for either. It's got all the newest self-consumption and TOU features, so separating out that DC side from the AC side and understanding where your power is coming from and going, and keeping control over the energy that you produce. It's also got that single button rapid shutdown, as we talked about, built into this unit. And you can order this with AMPLIFI or Phi batteries. So if you've got a cold environment these batteries are going into, and your customer wants the highest level of monitoring available, definitely go with the AMPLIFI batteries. Now the SolarArc's wired monitoring or wireless monitoring is very similar to Schneider's, except that in addition, you can have wireless programming. So you, as an installer, you forget a couple of settings, you go home, you research them, and you're programming them in from your home. You can also separate out, so the installer is programming the system and the user is viewing the system, but the user can't make any changes to the settings, or vice versa. Now, since we're talking about AC and DC coupling all day, I wanted to give a brief layout of the access unit and what it looks like. So if you're ordering the Schneider XW Pro, the AC grid generator, those are all on the same bus as the AC out. All the AC ins and AC out are kind of on the same bus. Same with your AC coupled array. However, your inverter is kind of the buffer here between all these power sources and the batteries. The charge controller would be on the DC bus if you've got a DC coupled array. So really, this doesn't change if you've got the SolarArc inverter. The layout looks the same, but all these things are hidden within the internals of the inverter. So you're not going to see the DC or the AC bus. Now we've got a lot of design tools to help you. Make sure to check out the battery sizing tool on our website to help your customer understand why they need 4 batteries or why they need 8 batteries, etc. And maybe even to help you calculate how many batteries they need in the first place, or double check your math. You can also feel free to reach out to us by phone or by email, 805-640-6700. You can reach sales or technical support there. And we've got manuals, integration guides, and spec sheets on our website. I really like to print out our integration guides before I go on site to do that programming. Make sure I get all the settings right. And lastly, I want to talk about our IQ program. IQ stands for Installer Qualification, so meaning we are qualifying you as someone who's able to install our product. You've proven you know what you're doing. We're going to add you to this map, show customers where they can find you and what your contact info is. And in addition, exciting news is we're now giving $25 cash back per battery installed. This is claimed through your warranty registration, and only Elite IQ members are eligible. So join our IQ program if you're already installing our product. This is a no-brainer. If you're not, we can help you through this first install to get you certified. And we are also launching a photo contest. So if you are installing our products and you want to make some extra cash, you can get $250 off your next purchase by submitting photos. Now, we really love to see photos of people and equipment, like this attractive guy here on the left. That might happen to be me, and installing batteries as well, all in one photos, but just send us what you got and we'll work with it. You can simply email me to join the IQ program. We can get you through the application. I can point out all the training resources that you need to get started. And lastly, I wanted to say thank you for joining, and I wanted to leave some time for questions. So my email is here. If you need NAPCEP credits, remember to shoot over your request with your full name so that I know how to address that. How many panels do you need for only one battery? Well, the amount of panels you need depends on the size of the panel and your loads. So it's not going to be able to answer that question without more details. How many can we put in parallel? With the PHI battery, you can put as many as you want in parallel. And with the AMPLIFI battery, you can put up to 75 in parallel. Is there an ongoing noise factor from your cabinet components? If you're talking about noise you can hear, no, they're very quiet. If you're talking about electrical noise, email me for more details. I'm not entirely sure. Are SMA Sunny Boy inverters compatible with AMPLIFI? So they're not compatible. They're not going to communicate with AMPLIFI, but the Sunny Island, instead of the Sunny Boy, if you're using a Sunny Island, that is compatible. Does the Boss 12 provide 1 hour fire protection? I'm not exactly sure if there's some specific type of rating or certification that you're looking for with this 1 hour fire protection. So I don't know how to answer this question, but it is UL 9540, meaning, and 9540A even, meaning it's been put through a forced thermal runaway event and it can withstand quite a lot. So let me get you some more details by email. I'd say check in with our tech support and we can answer that in a little more detail. Yes, we're still providing 1.5 NAPCEP credits. What exterior temps are access units with PHI batteries suitable for? So with PHI batteries, keep in mind that they cannot be charged below freezing. So AMPLIFI batteries will communicate to the inverter and tell it, hey, I'm cold, I can't accept any charge right now. Whereas PHI batteries do not have that capability. So you need to be careful to install them in an environment where they won't be charged below freezing. Besides that, I mean, they can handle any exterior temperatures. So for example, we've had customers use our access unit insulate the cabinet and install heating pads in the cabinet, and use our solution down to something that reached 0 degrees Fahrenheit without issue. In general, though, I'd say for these colder environments that are often dropping below freezing, please consider AMPLIFI batteries. Thank you. What is your name? My name is Matt. Sorry if I did not introduce myself. My name is Matt Walker. I've been here with SimpliPhi for 2 years. When will some of the cabinets become more available? I'm not sure what you mean. They're available right now. Our cabinets are even in stock at some of our distributors, and there's a very short lead time. You can order them today. My full name is Claude. Okay, don't, you've got to email me your name. I don't have a record of the question and answers here, so please email me for your NAPSEP credits. Do these inverters disconnect from the utility if they sense a loss of grid power, and automatically go into island mode, regardless of type of coupling? Great question. Yes, they do. All the inverters that we use, and even all the inverters that are legally allowed to be on the market, have to have that ability to disconnect from the utility built in order to be sold in the US. And this is not affected whether AC or DC coupling. So islanding mode is a requirement of all new inverters, meaning they will disconnect from the grid when they sense the grid is down. How do you integrate a vehicle like a Ford Lightning? So Phil, that's a great question. If you're trying to integrate simply a vehicle charger, this is much easier. You install it just like you would any other vehicle charger on any other home. You maybe would want to put this through your critical loads panel. It's up to you. If you want that power to be coming from the battery bank, that can go through your critical loads panel. If not, you can hook it up to your main loads panel. However, if you want your vehicle to operate and be able to back up your home, in addition to the battery bank backing up your home, this would be a little more complicated. You likely would want to have an automatic transfer switch so that either the battery bank, battery-based inverter are powering the home, or the vehicle, and so that they don't both power the home at the same time, for example. So this would be a good thing to see a single line diagram for, but often I think an automatic transfer switch might be able to handle that. Can the Solarc outdoor panel with batteries be used where outside temperatures can fall below -20 degrees Fahrenheit? That's a good question. Let me check on the specifics for you. We don't have any issue with the batteries going to as low as -4 degrees Fahrenheit. But if the outside temperatures are going to -20 Fahrenheit, you're going to need to insulate that cabinet and ensure the batteries are heated to some extent. So no, I think -20 degrees Fahrenheit would be too cold to not install heating pads and insulation. You definitely would need to keep the batteries at -4 or above to simply operate them at all. But this is not something that's, a restriction of SimpliPhi power. This is a restriction of really all lithium battery types, that they're not going to be able to operate well below -4 degrees Fahrenheit, and they're not going to be able to be charged below freezing. This is a chemical restraint of batteries, of lithium batteries. So, if you're going to put lithium batteries in that application, you're going to need to heat and insulate them regardless. We do have, experts in-house that have dealt with applications like that before. So we'd be happy to kind of help you along the road there with the system design. Suggested set point integration with load diversion. How does SimpliPhi deal with partial state of charge? So when you're using a load controller or maybe you're selling to grid, I think the best voltage to set your cell voltage at is 52.8 volts. This ensures the batteries are very near a full state of charge and that they sell the maximum amount of power they can. Now, you can of course set it higher. So, I mean, our batteries can float at as high as 54 volts, and that is what I would suggest if you want to maybe just sell a little bit and keep as much as possible in the battery bank at all times and keep them full for a backup scenario. But in general, if you're trying to, maximize your income from selling to grid, 52.8 is the recommended voltage. How do we deal with a partial state of charge? With lead-acid batteries, you will see sulfation if your batteries remain at a partial state of charge, but with Phi batteries and AMPLIFI, this is not a problem. They are not damaged by being at a partial state of charge for a long time. They have no issue operating many, many cycles without ever reaching a full charge. So it is beneficial to fully charge them, at least on occasion, but it's not required. Does your battery work with the grow watt inverter? Good question. There's a ton of different grow watt inverters, so I'm going to have to ask for more details there. We will look at the inverter model specifically. If it accepts, a low voltage battery and it's got programmable set points, then most likely it is compatible. How do we send our request from credits to training? Email me at training@simpliphipower.com to get your knapsack credits. Just email me asking for your credits with your full name. How much does the cabinet weigh with a Solarc? Currently, the Access cabinet is about 600 pounds with the Solarc. I can get more details for you if you email me if you want a very specific weight. We also have the option to provide an outdoor rated Solarc inverter that can sit outside, and then a Boss 6 is a smaller, more lightweight cabinet, half the size of a Boss 12, that can house 6 batteries. That is an option as well. Do the strings have to be 48 volts on an AC coupled system? I'm not sure if you're talking about PV strings or battery strings. The voltage of the batteries is usually, the inverter only accepts 48 volts in most cases. Check with the inverter spec sheet there. The PV strings will be a much different voltage, much higher than 48, I would hope. Is an ATS typically necessary when we have a generator? That's a great question. Think of your generator like an AC coupled PV array. So you do not need an ATS with an AC coupled PV array, and you would not need an ATS with a generator if you're using the generator to go through the battery-based inverter. The reason you need an ATS for your generator, meaning an automatic transfer switch for your generator, is if you're using that generator for whole home backup. So you don't want the inverter trying to power the whole home while you're using the generator to also power the whole home. That would be a very bad scenario. But you can have the inverter powering, the whole home while the generator is just adding some power to the inverter and to the battery bank. So if your generator is going through the inverter, note that the inverter already has that ATS or whatever is needed built into it. So you'd need an ATS if your inverter is not going through, excuse me, if your generator is not going through the inverter, if it's powering the whole home. All right, and then if you miss anything, know that I will be sending out the recording to this training YouTube link in about 24 to 48 hours automatically to all of you. So thanks for joining, everybody, and thanks for sticking around to the end. I will see you next time.